have three cases on this. Okay? We said that if tan is odd, and we did questions on this, and if secant power is even, and we have the third case, which is basically some special cases. Okay? Special cases include integration of secant alone, like integration of secant, or integration of tan cube, tan power 5 alone. This is like a special procedure. And integration of secant cube, which we did last time, or integration of secant power 5, and so on. So we did this, and if you want to do this, you do the same here. The same technique as we did here. Okay? So I did secant cube. We did also secant power 1, but I told you it's a formula, you just memorize it. That's then secant x was tan x. Yeah? I don't know if you saw, but I posted yesterday like integration and derivatives rule for everything you need to know. Yeah. Okay. Fine. So now let's do tan cube, for example. See how it works. Because we cannot apply. I know that the power of tan is odd, so you might think it goes under this case, but it's not the case here. This is not nice like sine and cosine. Sine and cosine, I told you, if one of them is odd, even if the other one is not there, I don't care. But here it's a little different with tan c. So let's do tan. Let's see how we do tan cube. Okay? So I cannot do anything here, there's no substitution to be done. So let me try to create an identity out of this. So for example, I could split. I could take a tan square out and then keep a tan. And then what is tan squared?
Secant squared minus 1.
Yes, secant squared minus 1 times tan x. And then you get tan x, secant squared x minus tan x. Okay? Which you can split on subtraction as tan x, secant squared x dx minus integration tan x dx. I'm just going to do these two separately. Okay? For this one, what do you think I should do?
Use substitution.
Yes. I see a function of this derivative, no? What's the derivative of tan? Secant squared, right? So u equal tan x, du equal secant squared x dx. So this becomes what? This becomes integration of u du minus, what is integration of tan? This is from the basic rules. Integration of tan is, anyone knows?
ln secant theta.
ln secant theta. Or secant x. Okay? This is again from the basic rules. Okay? And then integrate u, you get u squared over 2 u is tan x. So that's answer. Okay. I can do the same for secant power, for tan power 5. Another example. Integration of tan power 5x. Okay. What can I do? I can apply the same idea. I can pull I can pull a tan square, for example.
Keep tan.
And then
Square.
let's see. So I can do like tan square to convert it to secant square, and then tan cube. What's tan square? Secant square minus 1, right?
Yes.
So let me distribute them. I cannot do anything now. Substitution doesn't work because if u equals tan, then du equals secant square x dx. But secant square x dx is still not available here. So let me distribute like what I did here and split the integrations. So what do I get? Integration secant square x tan cube x dx minus integration tan cube x dx. Yeah? What do I get then? Now I can do substitution here. U equal tan and du equal
secant square.
So you get integration of u cube, right? Dx minus integration of tan cube. This is a simple integration. The substitution only here. And then this becomes du, u4 over 4 minus, what's the integration of tan cube? I just did it.
Length secant x.
I just did the whole thing. I just did the whole calculation for it. Okay? So what is it? It's gonna be, what did we end up with? Tan squared x over 2 minus tan secant x. Yeah? And then the u, you replace it with tan. And that's the answer to tan power 5. I think you had this question in the homework as well. Okay? Any questions? Does it make sense? Right? Okay, so I think that's good enough for 7.2. Let's go to 7.3, which is the numerical substitution. You have a quiz on Tuesday, right?
Yes.
With me. What is it on?
7.1, 7.2.
Only 2 sessions. Okay, good. So let's start with 7.3. Arithmetic substitution. Okay. Now the theory for this section is extremely short. Maybe you think this section is tough because of the long solutions. But the theory part is extremely short. So what do we need to do here? Now, if you see something, use something else. Okay? This is the section. I see something, I use a specific substitution. It's essentially a substitution. Okay, if I see any term that contains in the question x squared minus, or let me start with a squared minus x squared. Then I use the substitution x equal a sine theta. Okay? And if I see a squared plus x squared, then we're going to use x equal a tan theta. And x squared minus a squared, that's the last case. Then use x equal a secant. Okay? Now, in the first one, you're going to do some calculation, okay? And you should use this identity at some point. Sine squared x plus cosine squared x equal 1. And in these two, when you do the calculation, you will end up with a situation where you have to use this identity. Okay? And here also sometimes it appears sine 2x equal to sine x cosine x. Okay? So let's take examples of this. Let's take examples. Okay, example. Number 1. Integration of x cubed multiplied by x squared plus 16 dx. Okay, so which case is this? K. Okay, why is it done? Because I see x squared plus a square. Yeah? Or no? Why are you guys silent? This is a, right? That's a. So we see x squared plus 16, which is equivalent to x squared plus a squared. Yeah? So a squared is 16. I'm doing this in detail, you can skip it. So a is 4. So please don't use a to be 16. This is a very common mistake with some detail. Okay? Okay. So now we're going to use x equal a tan theta. Okay. Like the regular substitution we did before in calculus 1. We take the substitution and then we differentiate it, right? So let's differentiate the substitution. So the derivative of x is dx equal, what's the derivative of tan? Secant squared. Okay, now replace everything. What is x cubed? What to replace it with? What is x? 4 tan. So x cubed is 4 tan cubed. Okay? Times the square root of.
Something.
What is x squared?
4 tan theta.
4 tan theta squared plus 16. Okay, I'm not done. What is dx? Don't forget to replace dx.
4 secant squared.
4 secant square theta d theta. Very common mistake, people forget to replace dx. If you do that, you destroy the whole question. Do not forget to replace dx. Okay, good. Let's simplify now everything. What do I have? Integration 4 cube tan cube theta multiplied by. This becomes what? 4 squared is 16 tan squared, right? Okay, then what do I do? What can I do here? I can put the 16 out. So 16 tan squared plus 1. What is tan squared plus 1? Secant squared. Yeah, see? As we said, we will end up with something that is related to this identity. So I can replace the 16, I can replace the tan squared plus 1 with secant squared. So let's do that. Okay, so integration. So 16 secant squared theta. Okay. What is the root of this? Now it's nice. Now I can apply the square roots, huh? Yeah, 4 secant theta. You know you cannot apply square root on addition, right? Okay? You cannot apply square root on addition. Root a plus b is not the same as root a plus root b. But root a times b is root a times root b. And this is what we're doing. Okay? So 4 cube tan cube times 4 secant theta times 4 secant squared theta. Okay, let me clean this up. So I'm gonna kick all the constants out. 4 cube times 4 is 4 power 5. Push it out of the integration. And then I have integration of tan cube secant cube. Okay? What's this?
That's case 1.
That's 7.2. Case when tan is odd. Remember? So you need 7.2 maybe to solve 7.3. Sometime you might end up with something from 7. Okay? So be careful. And by the way, just remember I late, right? The question will only contain functions on this form. It will only contain algebraic. So don't think the topic is called trigonometric substitution and I have to see a trigonometric thing in the question. No, it's not necessarily the case. You only see algebraic and then you use trig functions to do the substitution. Right? So don't tell me I can do trig substitution for something like this. Can I? I see a squared plus x squared, but can I do it? No, because it has a tan. What's tan? Okay? These questions only contain functions in algebraic form. That's it. It doesn't contain anything in the other cases. Does that make sense? Okay? طيب, so what do I do when tan is cubed? Pull a tan and a secant. So pull a tan and a secant. Okay, and then what do? I replace the remaining tan with secant squared minus 1. Then secant squared theta and tan theta secant theta. Our variable is theta, not x, so please don't go back to x at some point without noticing. We're still working on theta. Now what?
U
Equals secant. So du is secant tan, which I can see here. This is what I put, you remember. So 4 power 5 becomes integration u squared minus 1 u squared du. And then u4 minus u squared du. And then what? Cross integrate. u5 over 5 minus u cube over 3 plus. Okay. Now we're going to replace u back to theta. Replace u. What do I get? Secant 5 theta, theta not x, and then secant cube theta plus c. If you stop here, it's wrong. Because again, I gave you the question in terms of x. You have to give me the answer in terms of x. So to do this,
Find theta.
we're going to find, it's not we're going to find theta, we're going to find any trigonometric function. How to find any trigonometric function? Make a triangle. If you make a triangle, then you're good. Now, go back to the original substitution. What was my original substitution?
Use
X equal
4 tan.
the trig substitution, I mean. The trig substitution. Go back to it. So x equal 4 tan theta, right?
Yes.
So x over 4 equal tan theta.
Yes.
If you remember from school the definition of tan theta is opposite
over adjacent.
over adjacent. So I have to draw the triangle with an x being opposite side of theta
and 4
being adjacent. And you know from triangles, if I know two sides, I know the third.
Correct.
From Pythagoras. So let me draw a triangle. You can put theta anywhere. The most important thing, the opposite to theta is x, according to this definition of tan, and the adjacent is this. Opposite over adjacent. And this guy from Pythagoras, 16 plus x squared. Notice it's the exact same expression in the question. 16 plus x squared. And that's not a coincidence. That should always happen. If that doesn't happen, you did something wrong. Okay? So you should end up in the triangle with one of the sides being something similar to the question. This is not a coincidence. Okay? So now I can replace secant. So this is from triangle. Okay, now maybe I don't know secant. If you don't remember secant, that's fine, but you should remember cosine at least. It's adjacent over hypotenuse, right?
Yes.
So what's secant? The reciprocal of cosine
Hypotenuse
is going to
over.
be hypotenuse over adjacent. So every fraction here I put hypotenuse over adjacent because my answer is the secant. So what's the hypotenuse? The root, guy. And the adjacent is 4. And then 4 and the root guy. And that's it. Okay? It's extremely long. That's it. Giving me approval of it. Okay, let's put more questions on this. Okay, which case is this?
Secant.
So x equals, what is a in this case? Is it 9? It's
Yes.
3. Yeah.
3 but then you will square root.
3 secant, yeah? Why is it secant? Because it's on this one, x squared minus a squared. A squared is 9, so a is 3. So x equal a secant. Differentiate the substitution. What do you get? 3 secant theta tan theta d theta. Now replace it all. So what do you get? Okay. What is x squared?
3 secant.
9 secant squared, right? Again, 9 secant squared, yeah? X squared is down. What is the x? 3.
3 secant. Down.
Work here. If you work here, you're gonna be using this guy. So let's do it. I have 9 secant squared minus 1, right? What's secant squared minus 1? So I end up with the root 9 tan squared, right? I'm doing it very slowly, but you can be faster than me. That's fine. Okay. What now? Tan theta,
Over 9 secant theta.
then 3 secant theta tan theta d theta. Simplify everything. Okay, I have 3 times 3 is 9, and then over 9 they all cancel together. And then I have what? secant and secant cancel together. So what do I have? Tan squared divided by secant theta. Now remember 7.2. When you end up with an integration, it should be a sine times a cosine or a tan multiplied by secant. Any other combination, you can simplify it through the basic relations of trigonometry. So what is tan squared? Or like what is 1 over secant? 1 over secant is? No. 1 over cosine is secant. So what's 1 over secant? Cosine.
No?
Cosine. That's it. So 1 over secant. This is not a new rule. This is coming from 1 over cosine is secant, no? Flip both sides. Yeah? So what do you get? Tan squared multiplied by cosine theta. Okay, that's still not helping me because I said it's either the sine times cosine or the tan times secant. So I have to simplify the tan.
Sine squared.
Tan is sine over cosine. So tan squared is sine squared over cosine squared times cosine. Cancel, cancel. What do you get?
Sine squared over cosine.
Sine squared over cosine. Which you can write as what? No. What is sine squared? No, I don't want that. Oh, we can do that. I was thinking of something else. No, never mind. Khalas. This is the simplest you can go. So what's 1 over sine? What sine squared is? 1 minus cosine squared, right? Over cosine. And then what can I do?
Cancel cosine. No, substitution.
No, not now. You can split. You can split. Make it 1 over cosine minus cosine squared over cosine is 1 cosine. Okay? Which
No, it's
simplifies to secant theta minus cosine theta, d theta. This is easy to integrate, this is easy to integrate. I'm done. So now what do I have? What is integration of secant? It's the rule. We discussed. It is len secant theta plus tan theta minus integration of cosine is sine plus c. But I cannot stop here. What can I do?
Draw the triangle.
Draw a triangle because I need to go back to x. That's the only way to go back to x. The triangle is only based on the first trig substitution I made. Okay, so recall, what's the trig substitution we made?
X equals 3 secant.
X equal 3 secant theta. So secant theta equal x over 3. So cosine theta equal 3 over x if you don't like to deal with secant. I know that cosine is adjacent over hypotenuse. So I draw a triangle with the adjacent being 3 and the hypotenuse being x, and I do Pythagoras here. What's going to be here?
X squared plus minus 3 squared.
X squared minus 3 squared, which is x squared minus 9, which is exactly the same thing in the question. This is how I know that I'm doing the right thing.
It always should be the same, right?
It always should be the same. Okay? You don't worry about the root that much, but the x squared minus a squared what? You know? Okay, so this becomes what then? This becomes len. Secant is what? No, we have it. X over 3. Or like you can read the hypotenuse and adjacent. Plus. Tan is opposite over adjacent. Opposite, adjacent. And then minus. Sine is opposite over hypotenuse. Yeah?
Yeah.
Wait, what?
Opposite over
No.
hypotenuse.
Guys, I did a mistake in the triangle.
It's
You
supposed to
didn't
be
write that
It's,
down also.
Nobody noticed I did a mistake in the triangle.
You.
adjacent.
Allah al-Azim, you guys should be. No. What's this?
Trusting
guys?
you like ChatGPT.
Huh? Everyone is dead because it's Sunday يعني. طب I woke up يعني. I should be sleeping now also.
طيب cancel.
ما هو مش على كيفي ولا على كيفك كمان. Cancel.
I want to sleep.
Where is the adjacent guys?
تحت.
Okay.
The opposite. So خربطت معي برسول.
Can you
سمونا. طيب خلاص. Let's forget about this now. Is this clear so far?
Yes.
Adjacent. Sorry, I just mixed the place of theta. Adjacent to theta, and the hypotenuse is the longest guy.
Yes.
It's always the hypotenuse is opposite to the right angle. And this one, the missing guy, we do the same thing. That's the question. طيب. Now we need to replace everything. What is secant? X over 3. Tan, opposite over adjacent. What's what else?
Minus sign.
What's sine? Opposite over hypotenuse. Yeah, خلاص. Plus.
Finish.
Finish. Any questions?
No.
just one?
Huh?
I was like looking at this question. When you finished integrating the secant theta minus cosine theta, is it just how did it become ln?
It's a rule. It's a
Okay.
rule.
I thought there was like
Integration secant theta is a rule. It's basically ln secant plus tan. You don't need to know where this came from. It's fine.
okay.
It's a rule. Okay. Okay. Let's do more. Let's do one on sine. We didn't do anything.
Yes.
You know what we should do? We should go home.
Okay. Let's do. I don't like this. Do you guys have homework on 7.3? Did you post?
No, no.
Not yet?
Not yet.
Hmm. Okay. Let me wait. There's a question, but I don't want to do it now. One second. Okay, I'll do this. Okay. So I see a squared minus x squared. What's a?
The
Six.
secant.
2? 6.
Go.
What's a as a what's a as a number?
6.
A squared.
No,
It's
oh, I
36.
mean A, okay.
So what's a?
Square root it.
6.
You get 6, yeah. My bad, that's the phone.
Substitution. X equals 6 sine theta. Yeah? And dx is?
That's why I said sine.
Sine theta d theta. Okay? So 6 sine theta divided by square root 36 minus what? What is x squared?
6 sine.
36 sine.
36 sine squared. What's dx?
6 cosine theta.
Okay. Simplify it. What do you think?
We square root the one that's down
6 sine theta.
over 6 minus 6 sine.
No.
We get
Take 36.
cos 36 cosine.
So 36 cosine squared, right? So root 36 cosine squared.
Then you cancel the cos. 6 sine theta and 6 cos.
6 cosine.
6 cosine theta.
6 cosine theta d.
Cancel. Yeah? So you get 6 integration of sine theta d theta, which is negative 6 cosine theta plus c. And then if I want to replace cosine, I'm going to make a triangle. What's my triangle? I'm going to use the substitution, the original one, x equal 6 sine. So sine equals x over 6. So opposite hypotenuse from the definition of sine, right? Opposite hypotenuse. So 36 minus x squared. Clear? And then what? So what's the answer? It was minus 6 cosine theta plus c. It becomes minus 6 cosine is adjacent over hypotenuse. You can just cancel these two guys and look at this guy. Okay? I think I can solve this question with substitution as well, right?
Yes.
Regular substitution. It works. Okay, let's do more. Let's do
Not bad.
which case is this?
The one that has x squared minus a. Forgot.
First one. A minus x.
You're guessing?
No, because I remember it was like
Huh?
something like this.
No.
It's not.
Which case is this?
You have 3 cases, right?
We have 3 cases: a squared minus x squared, x squared minus a squared, a squared plus x squared. Do you see any of them?
No.
Then we make one.
You
We
make
pick
one. I like this. You make one. You make the case. You create it. Okay? Why can I do this here? Because this is an integration of a function that I cannot solve with any other technique. Substitution, there is no function that's direct. It doesn't work. By parts, it doesn't work. There's like no 2 functions. Okay? It's very messy here.
Can we factor?
It's not 7.2. It's not factor. You can complete the square. You need to complete the square. This is the trick. Okay? And this is not partial fractions like 7.4 because you have a root.
Yeah.
That's the problem. So you cannot apply anything other than completing the square. So we need to complete the square.
I think I can use a calculator on this.
No. It's not. No, you have to know it. Like, because calculator can't
It
help you
will
very
simplify
much.
it for
Okay. Let's take it out first. Okay? So let's arrange it. Minus x squared plus 8x minus 7. To To complete the square, the coefficient of x has to be positive first. So I put the negative out. Okay? To complete any square, you have x squared plus bx plus c. You add and subtract b over 2 all squared. What is b in this case? 8 or, yeah. So we're gonna add, divide it by 2, you get 4. Square it, 16. So you need to add and subtract 16 here, okay? So x squared minus 8x, I'm gonna take what I add always, plus 16. And then minus 16, not to change the question. And then there is plus 7, don't forget about it. Math tells you that this is a perfect square. This guy, always again, the x squared term, the x term, and what you add. What you add, not what you subtract. The plus is a perfect square. This can be written as something square, like this. Root of x squared is x, root of 16 is 4, the sign in the middle is negative. This is how you do it.
Yeah, right. Sorry.
Okay? Minus 16 plus 7 is minus 9. And then don't forget there is a minus outside. Good? Now you can insert the minus back. It becomes 9 minus x minus 4 all squared. That's what I'm going to replace the square root with. Yes, Rashid?
I think this is like calculus 1.
Yeah. You do this in calculus 1 so many times. So which case is this now?
A minus
A squared
A squared minus x squared.
X squared. Now this you can treat it like the x. If you want, you can say let u equal x minus 4. This substitution doesn't do anything, but it just makes you see it in a better way. It's up to you. So it becomes 9 minus u squared d. Now it's very clear that this is the sine case, a sine theta, right? Okay. You don't have to do the substitution. I'm just trying to show you that this is a squared minus a block squared. Okay? So like a squared minus anything squared, you do the substitution, that thing equal a sine theta. Here we used to put x, right?
Yes.
But now we can put anything. It doesn't matter. Here in this case, it's x minus 4, yeah? It's x minus 4. So I can say x minus 4 equal 3 sine theta. Take the derivative to both sides. Dx equal 3 cosine theta d theta. And replace now. Okay, 1 over 9 minus x minus 4 all squared is 9 sine squared. Dx is 3 cosine. Okay? And let me pull the 9 out like usual. Now خلاص, we need to use an identity. Let me pull the 9 out. 9, 1 minus sine squared. 3 cosine theta d theta. What is 1 minus cosine squared? Sorry, what's 1 minus sine squared? It's cosine squared, sorry. Theta. What do I get? 3 sine, right? 3 cosine? 3 cosine, sorry, 3 cosine. Now what do you have? Cancel. So integration of 1 d theta, which is theta plus c. Yeah? Now to replace theta back to x, I look at my substitution. What is my substitution? X minus 4 equal 3 sine theta. So sine theta equal x minus 4 over 3. But I don't need sine theta, wala cosine, wala tan, wala secant. I don't just need theta. So what do? I can do sine inverse. that's the final answer. Sine inverse x minus 4 over 3 plus 6. Okay?
Yes.
Any questions? Sorry. One second. So next time I'll start 7.4. Let me just take attendance quickly.